Today, we're just going to walk through a really quick example of using a AI agent to investigate a SRE network or application performance issue within ExtraHop. So I'm going to go ahead and kick off this prompt, and then we'll talk while it's going. So what you probably notice here about the prompt that I just kicked off is that it's pretty simple and doesn't include a ton of information, which has a lot in common with a lot of the incidents we have to look into. So we had a performance collapse that happened a few days ago, and I am really just asking the agent to investigate that. And the only real opinion I'm offering here is that I would like it to write up a report once it's finished. And I'm of course dropping a little bit of a hint here by using the word thorough as to how hard I wanted to work on this. So the agent we're using today for this demonstration is Claude Sonnet 4.6, and we'll be able to kind of see the session information here on the lower left. However, this approach would work with really any model that you might be using. Now, due to the magic of video editing, I have trimmed out a couple of minutes while this agent performed its investigation. So we actually have all the outcome data here for us to examine together, save us some time and get through this video together. So as we notice here on the lower left, the context bar has filled up a little bit. So the agent used about 17% of its context window, or around 170,000 tokens get stored in order for it to complete this investigation. And there's a lot of information here around tool calls and actions that the agent take. We can inspect a few of these as we go for fun, kind of see some of the things it was doing. But what I want to point out here mainly is kind of how this works, which is that the agent will make some tool calls. So like in this example, it made what it felt like was a critical discovery around database. And after making this critical discovery based on the outcome of the previous loop, it was then able to decide to run a couple more tool calls, and we can look to see where it's inputting commands and pulling records, right? So for this particular tool call. So for tool calls, it's going to do things like pull records, pull metrics, look up entities, look up detections, etc. So we can look over here on the right pane now that we have this workspace files populated. I can expand evidence, and we can see that it did quite a lot of work here. So we can see that it was able to assemble 37 unique pieces of evidence. And you can kind of think about it like this. So like when you're using ExtraHop as a human, you click on a dashboard, you click on a device page, that makes an internal JSON RPC tool call to ExtraHop from the web UI that presents after this API call data to you, right? So every time you're clicking on a new page in ExtraHop, you're effectively making a request similar to one of these 37 pieces of evidence that was collected. The difference here is instead of them being presented to you in a browser, they're presented to the agent as a blob of data, and the agent can write it out to a file, which allows it to store or preserve its evidence investigation, chain, all the things that it looked into, all the things that it did for later inspection, giving you, incidentally, like an offline copy of the investigation to store. But also, it allows the agent to be really efficient with how it looks at things. So it's like every time it loads a page, it's sort of like caching that page. So if it wants to go back and look at something again, sort of like you might do, that information is all there ready for it. So we can see in this investigation, it looked up 2 detections, it looked up 4 different devices, pulled 15 different types of metrics, and did 16 different record queries. So we can just inspect a few of these. I can open up entities here, and we can click on one of these devices. And this is just to give you kind of an idea of what it's getting back. So if it wants to look up a device, it gets JSON back, which is the language of agents, and we can see it can see things like the analysis level, the role, database server. It can look to see what the name of it is. It can see what its default name is, also giving it a clue that this is some kind of VMware virtual machine. Quite a bit of information here: IP addresses, MAC addresses, etc. So it's able to get entity context, and then it can use this context to further investigate. Similarly, it's able to pull in metrics, records, detections, et cetera. All that data is here available to it. And then it might use, some sort of a working directory to write scripts to pull things or to perform calculations locally. As we scroll down here, though, we can see it's doing quite a lot of this, right? A lot of tool calls, a lot of information being checked. We can expand some of these and see the actual reasoning, where this is the part of the process that you don't typically see, where the agent is talking to itself as it thinks through the problem. But yeah, if we scroll all the way down here through lots of reasoning and lots of tool calls and get to the bottom, it says that it was able to write a report And it's also printing out here an investigation summary. So it's breaking out what occurred, breaking out what metrics it saw, what calculations it did, all the things that you as an ExtraHop expert might have needed to do. This really nice table here showing you the different metrics it pulled and highlighting in bold the numbers that were most interesting to it, as well as suggesting follow-up actions. Now, because I asked for a report and this agent is equipped with a skill that gives it a template for a report to fill out, it has done that for me and we can actually inspect it together. I'm going to click right here and open this up. What I'm probably going to do is download this so we can view it in full screen. And then we'll just zoom in here a little bit and look at this together. So here at the top, it's written out a summary for us of the information that occurred. Now we could read this together, but I'd rather scroll down and we can kind of inspect the overall landscape of what it did in timeline. What I really am looking to show you here, though, is how it's able to assemble this really coherent timeline from events. And unlike you or I, where as we drive through ExtraHop and look at many, many different screens, we sort of half remember some of the stuff we saw and what was interesting, and we go back. This is able to do a really incredible job of holding on to all the different things it's looked at, largely because of the way it writes it out to files, and then really efficiently go back through everything it's seen and piece together the whole story. It's something you and I can definitely do with a notepad and our experience of investigating things in tools in general. But it's really nice to have to see how effectively this can be done, even when hands off. So here is an interesting view that it produced for us around the events that occurred, and then the actual real timeline of events. So we can see that there were effectively two incidents here. One was this database IO stall, which resulted in this page fault with this large increase in latency, followed by the database issue being resolved, and then shortly hitting this PHP worker pool exhaustion, and then eventually that was resolved as well. And here we have a timeline all pulled from exclusively ExtraHop data, showing what the baseline performance was based on metrics for the database server, what the onset looked like of the incident that occurred. The first slow query that we saw, it took 123 milliseconds, and then within 2 seconds, all queries across all tables locked to this time frame. We're able to kind of see what this does to downstream latency, able to see how long this incident lasts, when it was resolved, additional information, and such a wealth of information in here showing us all the individual results of metrics, building things for us like these hero cards showing us exactly what occurred and what the deviations look like. I really like this Q&A section that I have built into this report, where we're able to see where the agent kind of talks us through in a Q&A fashion what occurred. So, where is incident one latency introduced? Was this a network issue? Was this an app tier issue? Or was this a backend issue, a database issue? And it's able to answer for us, look, this was exclusively a database issue, and here is why, right? We observed this database server processing time spike up to 150 milliseconds. And then we were able to see how the downstream web server processing time that depends on the database rose proportionally, right? And so all of this is the sort of things you'd expect from a human engineer. And it's able to do this and build us this great consumable way to understand what occurred without us spending a lot of FTE time in the platform. So we'll scroll down through a few more of these. And as we get down here to the bottom, I wanted to call out a few more things it does. So it gives us this root cause analysis, breaking down what each of these root causes were. What I also wanted to call out here, and we'll look at it here as we scroll down, is how it's able to also share us the hypothesis it considered. So what are some other possible causes? And kind of how it arrived at its conclusions about these other hypotheses that came up. It gives us a manifest of all the evidence that it collected and what these map back to. So I think the mappings are interesting. So if I scroll up through here, we can see these E callouts. So E3, E4, and we go back up to timeline, we see E6, E7, E8. These are all references to the evidence. This makes the investigation very human inspectable, right? So if one particular step in the chain is something that you're not sure that it adequately explained its reasoning, and you want to double check that, or you find that to be suspicious, you can go inspect the evidence yourself. You can go down and say E3 database transaction records. It says this particularly query tool call, I looked up these type of records. So I looked up database records with a filter of this particular server and from this particular client. These are the ExtraHop device IDs. What timestamps until and from, and then we can go look at the file right here that was collected and inspect that for ourselves, or we can literally just take the actual database query, records query, and go to ExtraHop UI and rebuild that query in the UI using EQL and look at the same records ourselves to see if we agree. Finally, it comes down here, and I also think that this is quite an important thing to implement in your agent workflows, which is a self-inspection around like where my confidence breaks down. So checked and clean, these are the things that ExtraHop confirms completely and that it has complete confidence in based on the data observed. Could not determine is really valuable. So this is the areas where it has opinions but can't prove it. I think this is a really good example here, actually. So it says, look, I have a hypothesis that this was caused by VMware snapshotting. And the reason I think that is because, and it talks earlier up here about why it thinks that. We can scroll up and find it, but essentially, right here. So it basically talks about how the way that this behaved, so a hard ceiling of database response time that propagated with this kind of hard cap of 150 milliseconds, with this kind of instantaneous onset, this pause gap, and then this sort of simultaneous instantaneous recovery is very consistent with VMware snapshotting. And it, as we saw earlier, observed that this device in ExtraHop has a default name that begins with VMware based on the MAC address. So it's able to further kind of infer, like you or I would, that this is probably a VMware virtual machine based on that metadata. And the behavior we observed looked a lot like a snapshot. So I think that this is very interesting and is able to kind of inject that broader knowledge into the investigation beyond simply being localized to just the data in ExtraHop. But then being honest with us about, how confident that is. It does this for a few more things. Talks about some things that we simply can't see, like ExtraHop can't see the internal VMware host metrics. You need to go check that out. And then suggests some good follow-up actions, right? So you want to stabilize, you want to verify and investigate. So you're going to want to go pull host level diagnostics for the PHP issue it believes it saw. You probably want to go review vCenter change calendar because it believes that this could have been a snapshotting issue. And then prevention, like you might want to add a database storage latency alert rule in ExtraHop. So yeah, this is just an example of how thorough an investigation using only ExtraHop data can be. And what I find to be very interesting here is that if we were able to zoom this out and we were able to give this agent access to to VMware reporting and access to other data sources, a log store, for example, then it's able to actually go fill in gaps even further on its own. But I think it's really amazing how far an agent is able to get using only the data in ExtraHop. And it's really revealing at how much, to what extent we've actually been tapping the data that's available to us in ExtraHop. Because in many cases, as a human investigator, if you look at this report, the amount of human hours it would have taken to build and comprehend this much data from ExtraHop is way more than I think we might think at first glance. Like we look at this and say, yeah, it kind of did all the things I could have done. But if I think about if I would have literally done all of this, this would have probably taken me a few hours just to look at all the information. And then I have to be a little bit, I have to hold the hubris in my brain that I would have stitched all the pieces together this well and on my own. And maybe I would have. I think if you gave me enough time and a notepad and I were to use a calendar and like build out this timeline manually, that I would have arrived at a lot of these same conclusions. And I don't think all of the evidence that was collected here was particularly well hidden. But the outcome of being able to spread it all out for us so cleanly, and then the fact that it's able to purpose build, an artifact that we can review together easily to experience this information and internalize it and understand it, is just it's really I think pretty impressive. And I think most importantly, it shows the capabilities and the possibilities here for reclaiming literally hundreds or thousands of hours a year in FTE time looking into incidents. And I think just as importantly, the hours this can shave off of incidents is incredible, because if we'd have been able to point this at this issue with our simple, what, 25, 30 word prompt early on in the incident, then it could have saved us potentially hours of an outage, which is obviously critical. So I hope that this was informative. I want to call out, though, real quickly, that nothing we're looking at here today is ExtraHop proprietary on my screen. So this is just a generic coding agent with a simple UI that I wrapped around it myself. This is not an ExtraHop product that you're looking at here. What I'm just trying to do is show like an easy user interface experience to walk you through what this can look like, and also expose a little bit more of the information to you in kind of a purpose-built way. I think one of the very exciting things about agents is that you're all free to go do this. So you can definitely go wrap your own interfaces around your own agents. The only thing that was necessary to make all this happen was a copy of either the ExtraHop MCP server or ExtraHop CLI. And then, of course, there is a template for this report that I provided to the agent. So those are the only parts here that were provided. Everything else here is just a Pi coding agent with its SDK exposed to a simple local web server that I have painted up to look a bit ExtraHop in nature and give us a uniform experience to kind of inspect the agent's work, et cetera, so that we didn't have to look at a CLI or a generic, Claude code or something like that. I wanted this to kind of be abstracted away from those specific individual products and tools from those other companies. So yeah, hopefully this was informative. I'm just Thomas at ExtraHop. I'm really happy to talk about any of this, answer any questions. If you want any help with your agents or getting them to be successful with ExtraHop, if you would like a copy of the ExtraHop CLI or MCP server, those are available through the Agentic Ops group on the ExtraHop customer forum. If you're interested in any skills or help with skills around reporting or around processing data, we're also always happy to help with that to the best of our extent to try to help make you be as successful as possible with ExtraHop.